Hi, what I'd like for you, or to do for you with this video is to kind of illustrate some very basic digital, or excuse me, descriptive statistics. Now, some of you that are familiar with statistics and so forth, this is going to be so basic and so forth. I just feel like with action research, we still have people that get numbers. So what do you do with those numbers? Typically, if you have a Likert scale or something like that, you usually calculate a mean, a standard deviation. You might even calculate percentages of people that answered the different answers, but usually you would get a mean of some kind because, again, when you're looking at your data, you're really evaluating the data as a group. And so it isn't like you want to get every student or every colleague, whatever, identify their score individually. What you want to do is you usually want to work with group data. So I'm just going to show you a couple of very quick things just to make sure that we're being at least honest with the data that we have, and we know how to report them as well. Okay? So what I have here is I have a spreadsheet that has 71 students, and what I have is scores to digital story. Okay, so they did a digital story as a group, so you can see that these scores are in actually almost groups of 4 because there were 4 in a group, and you know, they can get the various scores here in terms of, you know, accuracy of facts. 15, this group got 12, 15, 14, whatever. Okay, so the first thing that I need to do is I need to get a total for these rubrics, like out of 100, how did these students do? So I'm in Excel, but you could be in Google Sheets or whatever, just any standard stat spreadsheet package would do these basic statistics, okay, of which we call descriptive statistics. So in this first one, if I just go up, and what I'm going to do here is I just want to sum it. And nice that these packages, they're kind of ultra smart, and so they pick up the numbers, they highlight the ones that you think should be added into that sum, but always make sure that it goes far enough over, far enough up, whatever you're highlighting. So I'm just going to press return, and the total number of points in this one is 86. So that's pretty easy and works pretty well. Now, what I want to do is the other thing that statistic packages do for me is they let me fill those formulas down or up or across so that I don't have to type it in for every one of those. So when I release my mouse, you can see that it has calculated all the sums for those 71 students up and down the sheet. Okay? So next, then, I have my totals. So what do I want to do? Well, I probably want to calculate the mean now. I want a mean average score for this assignment for my students. So how well did they do as a group? Okay. So again, somewhere in that program, you're going to have built-in formulas, and in that case, this is where I'm finding it in Excel. I'm going to get the average. The average is the mean, okay? But usually with statistics, we do report it as a mean, okay? And I'll show you that in a minute. So again, just make sure that it's highlighted all the numbers that you want. And then, actually this one didn't, I can tell. I'm going to go back. I'm going to just delete that out of there, excuse me. And I'm going to go back up and do average again, and I want it to pull up. Okay. I'm having my mouse, I don't know if I'm on my screen capture and it's just not letting me or what it's doing. We'll see how this looks when I see the whole thing here, but what I want to do is I just want to pull it down. It shouldn't really be this difficult. There we go. It's going to work. Notice K2 through K71, and then I say OK, and it was 44.9. I guess that was what it was. So that's the mean and how you calculate the mean. If I report that out what I would do is just put m equals 84.9, and that's how I would kind of write it up. That's what I would say, you know, mean equals the 84.9. So that's how you would just put it in your document. Okay, something like that. Okay, we would know that's what it is. Okay, the second one, this one is a little bit trickier. We'll see if it works. The other thing that with a mean usually comes a standard deviation, because what we're doing is we're interested in knowing how many, you know, what's the spread of the scores in a normal distribution. And so think of your bell curve, and really for a standard deviation, what you're doing is you're figuring out how many people above 1 point of standard deviation and how many below fell into that range. And so how many points above the mean, how many points below the mean are 66.6% of your students, okay? So you're figuring out that standard deviation. Obviously, this one will be a little bit wider because our scores, we have more scores. If you're working with a Likert scale, that's going to be smaller, okay? So I'm going to go up, and this time, you guys notice I don't have standard deviation, so I go into more functions. Mine's right at the top because I've been using this, okay? So keep in mind that you might have to go down the list and find it in alphabetical order. So I'm going to insert the function, and then really you do the same thing again. And since my mouse is being kind of silly here, I'll just key up and get to 1. And then I want to do that same thing where it lets me here. I pull it down, and that's my range of my first number, okay? And that's actually all I need, okay? I can now say done, and my standard deviation is 7.52. Typically, you do go maybe to the second digit. I don't think you have to go to the third or, you know, even that mean if you want it, but be consistent probably. But what this is telling me is that most of my students in this class scored about 8 points above the mean to 8 points below the mean. So there was a pretty good spread of 16 points in terms of their performance. And so that's kind of how you want to interpret that. Again, if you're using a Likert scale of 1 to 5, you're not going to have much of a range. In fact, maybe you don't want to have much of a range. But that's how you would think about that. Okay? So the other thing that I want to show you is using a t-test. Okay? And with the t-test, again, typically what you're doing here is you have a pre-test and a post-test, and you want to see, did they get better? You know, have they gotten better between it? And so what you really have to do is you need that score. You need whatever you're comparing from the first time to the last time. And you need to set it up like that. So like my spreadsheet here, I have 20 students in this class. They took a pre-test. That was their score. They took a post-test. That was their score. Okay? And if you just look at the data, you'll notice, well, it looks like the students did better on the post-test. So they must have learned something. Okay, now sometimes your data doesn't look like that, or sometimes you have 100 students, and so it's hard to see. So you run the statistics to see how they have done. Okay, so what we're going to do is we're going to go up, and I'm going to go to more functions again, and you can see that one of my selections is a t-test. Okay, and so that's kind of what you want to look for in your statistical package or in your spreadsheet. So I'm going to insert that function, and this one, you guys, the array 1 would be your pre-test, okay? Array 1 would be your pre-test. Array 2, you move your cursor, that would be your post-test, okay? Then it asks for tails, okay? Two-tailed distribution or one-tailed distribution. Two-tailed distribution would be more kind of equal distribution. So we're gonna say 2, and then we need the type. This is important. 1 2-sample equal variance, that's paired, or 2 is unequal variance, okay? Or excuse me, paired 1 2-sample equal variance equals 2. Okay, I'm looking to see 1 is paired, 2 is 2-sample equal variance, 3 is 2-sample unequal variance. Well, this one's easy because it's a 1. Paired means it's the same group. The pretest for one student is matched with the same student for the post-test. Now, when would you have like the 2 and 3? Because those are examples where maybe I give a test to my college students in the fall, and then I give the same test to the students in spring. It's a different set of students, so it's not a pair, okay? It would be an independent t-test and not a dependent test. So that's what we're doing here. Okay, so I'm just going to say done. And now this is what we get. And that probably doesn't mean too much to you. So I think what we have to do is I'm going up to format and I'm going to the cells. And what I'm saying here is I'm going to do number and I'm just going to give it a lot of decimal places so that you can kind of see what it looks like. Now, there you go. This is a very highly significant difference. So what we say is the pretest to the posttest is significantly different. And usually in educational studies, we say 0.05 is, well, when alpha p is less than 0.5, it's significant. So, not equal, it's less than 7, like that. When that is less than 0.5, something is significant. Well, obviously, ours is, right? I mean, ours is definitely, this is less than this, okay? So if it would be more, if this came back 0.105, then it would not be significant, okay? So how we would probably say for this one is we would say P is less than 0.001. You never say 0, like just 0, because a number just isn't 0, okay? But if you leave it like that, it usually works, and it usually works pretty well. Okay, so basically your t statistics for this is going to be at the alpha level is going to be this. Okay, so that's how you run a t-test. That's how you know if it's significant or not, and it usually works pretty well. So I hope this real short tutorial helped you with getting your mindset into using a few descriptive statistics. If you need any help with anything, always just let me know. I'll be happy to run the tests for you to a degree, but you know how to set them up now, so I think you can do them yourself. But I'm happy to help, okay? So hope this helps.